Hi, welcome back, Intro Stat students. So today we're doing an exercise on conditions for a t-test about a mean. T-test is only used for mean, right? So when the data is actually of a quantitative nature, you have to use the t-test. Okay. All right. Let's talk about the conditions. So mainly is this, all right? Mainly the conditions, there are three, okay? The three conditions, right? The three conditions for a t-test, okay? All right. So first of all, it needs to be SRS, right? Simple random sample or from a randomized experiment, okay? And that is easy to look at and to distinguish. Now here, um, remember for proportion, sorry, for proportion, oh, it's not as sensitive here. For proportion, right? Three conditions for z test. So z test, right? For proportion. Same thing for SRS. Now the normal rule, no normality rule is what? Is the p, right, times one minus p. Actually, no, my bad. It's the n times p greater equals to 10 and the n times 1 minus p greater equals to 10. But for mean, right, for a t-test, we're looking at sample size if it's greater than 30, right? That means central limit theorem is applied, right? Central limit theorem is applied. And that's basically just said that the sampling distribution of the sample mean, right, it's approximately normal. And third condition is the 10% rule, right, which is also known as the independence rule, right? And that just says that the samples are independent from each other. Okay? So keep that in mind, the three rules. So if you look at this, Sunil and his friends have been using a group messaging app for over a year to chat with each other. He suspects that on average they send each other more than 100 messages per day. That's a lot of messages. Sunil takes a random sample of 7 days from their chat, right? 7 days from their chat history and records how many messages were sent on those days. The sample data are strongly skewed to the right with a mean of 125 messages and a standard deviation of 44 messages. He wants to use this sample data to conduct a t test about a mean. So here it says random, right? Random sample. So we know that the data is a random sample. Now we need to look at our sample size. Right? Our sample size is only 7 out of how many? Did they say? No, they didn't say. So 7 days is less than 30, right? So if it's less than 30, now as long as the sample is not skewed, so here it says that the sample is skewed. So let me go back and perhaps rewrite this a little bit. So if the sample size is less than 30 and CLT is not applied, CLT, which is central limit theorem, is not applied. Okay? So as long as it's not skewed, as long as it is not skewed, not strongly skewed, strongly skewed. By the way, skewed. This is skewed left. This is skewed right. So as long as it's not strongly skewed or have outliers, it can be assumed to be normal, right? So as long as it's not, if it's less than 30, unfortunately, if it's more than 30, central limit theorem is applied, then boom, that's it. You know that it's approximately normal. But if it's less than 30, CLT is not applied. And then you need to look at the sample distribution. As long as the sample distribution is not strongly skewed or have outliers, it can be assumed to be approximately normal. So look at this. It says that the sample data are strongly skewed to the right with a mean of 125 and standard deviation of 44. And it has a sample size less than 30. So this sampling distribution of X bar sample mean is approximately normal. We cannot check that because we don't know. All right. So since sample size is 7 and we assuming that the population, right, is the population size going to be more than 10% of the sample size. So if you multiply this by 10, 70 days. So do you think over a year has 365 days. So 365, sorry, 365. And if you multiply that by zero point 0.1, it's 36 days, right? And they only make 7. So, which is a lot less. This 7 is a lot less than the 10% of the population size. So that means that individual observations are independent. So check this out. Here are two different samples drawn from two different populations. Sample 1, sample A. Ooh, N is 13, which is less than 30, and yet there are outliers, right? There are outliers. So this is not symmetric, right? It has outliers. So that is not, you cannot use that. And this is strongly skewed, but skewed to the left, but it's 34, which is more than 30. So sample B satisfies the normal conditions for performing a t-test. So hopefully this makes sense. And let me know if you have any question. I can do this quickly. Let's see. A website streams movies and television shows to millions of users. Employees know that the average time a user spends per session on their website is 2 hours. So the website changed its design and they wanted to know if the average session length was longer than 2 hours. They uh, randomly sampled 100 users. Wow, this is more than 30. And found that their session lengths had a mean of 2.75 hours and a standard deviation of 1.55. So we need to look for three conditions. Is it a random? Yes, randomly sampled. So we know that a random condition is satisfied. 100 user, which is more than 30. So I know that the sampling distribution is approximately normal. And I need to look millions of users. So with 100, yeah, that's enough. It's definitely right considered independent. So let me know if you have any questions. Hope you guys are well. Take care. Bye.